All right, here is the greatest integer function definition. When you see this notation of int or a double bracket with an x, it represents the greatest integer that is less than or equal to x. So below here are some examples of evaluating the greatest integer function. So when we evaluate it for 1, I'm going to create a number line here. Here's 0. And we evaluate it for 1. 1 is an integer, so your output will be an integer. When we evaluate it for 1.3, here is 1.3 on the number line. So we have to round down to the nearest integer, which would be 1. So when we evaluate 1.3, we get 1. Now let's do 1.5. 1.5 is not an integer, so we round down to 1. 1.9 is still not an integer, so you round down to 1. And I'm just going to erase those numbers on the number line. And we will do some more examples. So here's 0, 1, 2, and 3. So evaluate the greatest integer function for 2. There it is on the number line. It is an integer, so your output will be another integer. Now do 2.3. 2.3 is right here. That is not an integer, so you round down to 2. So your output will be 2. Evaluate it for 2.5. Here's 2.5. It's not an integer, so you round down. And you'll continue doing that. Notice what happens when you jump from 1 to 2. When you go from 1 to 2, it's going to give you an output of 1. If you go from 2 to 3, you're going to round down to 2. So that's what that's saying. So here is what the greatest integer function looks like graphed out. Its nickname is the step function. So when we graph the ordered pairs, if I evaluate it for 0, I get 0, and then all numbers between 0 and right before 1 will round down to 0. Then I go to 1, I get 1. Anything between 1 and right before 2 rounds down to 1. So these are the little steps that occur when we graph the greatest integer function. And again, the notation you'll see is the double bracket is the most popular. All right, next example is graphing a piecewise function. So here is our function, and the first piece is saying f of x equals 3, and then there is this domain restriction. So what we're going to do is we're just going to graph y equals 3. That's a horizontal line. The slope is 0, and the y-intercept is over 0 up 3. So I'm just going to expand a little bit. All right, so here's 1, 2, 3, 1, 2, 3. And we're going to create a horizontal line running through at 3. Now we're going to take into consideration this domain restriction. It says, keep anything where x is less than or equal to -1. So we're going to go on the x-axis to -1. We'll go up to that purple line, and we're going to keep anything where x is less than or equal to. So this is what we're going to keep right here. So I'm going to erase that section, and keep anything less than or equal to -1. So that's the first piece. Now I'm going to change colors just so you can see the other piece that makes the function. It says f of x equals x minus 2. So I'm going to write that as y equals x minus 2. Our slope is 1, and our y-intercept equals -2. All right, so to graph that, we start with the y-intercept of -2, and then we have a slope of 1. So I'm going to rise 1 up and then right 1, or I can go down 1, left 1. And I'm going to just create one more ordered pair there. All right, now here is the line without any domain restriction. Now I'm going to take care of the domain restriction. It says keep anything where x is greater than -1. So we go on the x-axis to -1. We go down to where that graph starts, and we're going to keep anything greater than, so anything to this direction. So that means we're going to erase anything less than -1. And we notice that there is an open circle right here, because it cannot include -1. So what happens is we have this piece here and this piece here that creates our function.